Good morning, all. Today we will be discussing about uh, the linked list that we had covered on Monday. Okay, I'll be continuing with that, and then we will be discussing a very important concept which is called as comparator in Java, wherein I can accommodate comparator in generics so that I can write a generic function which works on all the set of data types. Okay, so let us see that. We will go ahead with the program that I have left out in between in the last class. Okay, I think we were discussing about iterator in the previous class. When I, the iterator class, okay, this is what is the example that we have discussed in the previous class. Here I was talking about creation of an iterator object. Using that iterator object, how can I print every element without explicitly iterating as I do in C program? Okay. So I think if I if I'm not wrong, if you can recollect, this is the example which we were talking about in the previous class, where I was implementing linked list operations like insert first, insert rate, remove rate, and display. And I also compared how we used to write in C program and how a modified version of the things are there in Java. So all those things we had discussed. We were at a point where display function was getting the fifth option, display function. This was the point of discussion in the last class. Okay. So for displaying, we don't have similar to the for loop that we use. Instead of that, we have a special class called as iterator class, which we had discussed in the previous class. Okay, so in this line of program, I have created an object of iterator. Okay, and using that object, see, whenever you're creating in the iterator, the the iterator function, when you're calling the iterator, when you're calling, it has to be called on the object with which you want to attach that iterator. Otherwise, see, if I write like this, suppose, okay, if I write like this, if I write like this, then this iterator is attached to what kind of data, that is unknown. That is unknown. That's why I need to have the attachment of this iterator with the object with which you want to have the iteration done. Okay. So whenever you're creating an iterator object, the right hand side must contain the object to which, or the collection class to which you want to attach the iterator. Okay, this is very important. You cannot use new as we use normally in Java. New is not useful in iterator class. Okay, so here when I take up creation of an iterator object, see, this iterator is associated with very important functions like has next. I'm just putting all of them together. It has something called as has previous. It has something called as next. It has something called as previous, and also it has something called as has more elements. Okay, I'm just typing all those things for you. You can just have a look at this. These are the different functions that are available as part of an iterator class. Okay, and iterator can be used on any of the collection class. I think this is where I stopped in the previous class. Okay, so what are these functions that I have listed? Has next will return true or false, whether I have any more, I have the next element or not. It doesn't check for all the elements, it just checks whether the immediately available element is present or not present. So returns true or false. Then has previous returns true or false based on the previous element if it is available or not. Next will fetch me the element available next to the current element. How has next is different from next? Has next returns true or false. The return value of has next is boolean, but the return value of next is e. It means it can accommodate any data type, the element, the data typed element that is available in the collection class, that data typed element gets returned. So return type of next is not boolean. In fact it returns the element itself. Similarly, previous also returns the element itself. Has more elements returns boolean. So has more elements returns a true only when there are more number of elements available. Okay. So how we used to write in data structures? We have written n number of examples in data structures. Okay. So when we used to iterate through a linked list, we used to call current arrow next is equal to, sorry, current arrow link is equal to null. If current arrow link not equal to null, then I can proceed ahead. So that is taken care by this iterator automatically. So there is a helper for this iterator. That helper is either has next or has previous. When I use has next, you must use next. When I use has previous, you must use previous. See, if you use has next and you try to use previous, that will never work because they work in pair. Has next must use next. Has previous must use previous. Okay. Has more elements will come into picture when you don't know how you want to go ahead. You want to go ahead in the in ascending order, you want to go ahead in the descending order. In whichever format you want, you can go ahead. Okay. In this example, I'll be showing you in the next 4 lines of code how you can navigate in the ascending order of the linked list, how you can, then I will be showing you how you can navigate in the descending order of the linked list. Okay. Now in this line I have written while loop having itr object used as, along with has next. So it returns true only when the next element is available. If it is true, then it enters the loop and prints itr dot next. It prints the element next to the current element. Okay. So it continues until it reaches the last element. This continues until it reaches the last element. Then if I want to print the same linked list in the reverse order, you just remember the code that you have written for reversing a linked list. Or if you want to reverse a given array, what is the amount of energy or what is the amount of code that is required? See, you just try and analyze that. In Java, it gives me in one line of code. This is why Java is more preferred if you are writing much more linear programs. Okay. Um, just 1 minute, I will unlock the meeting and then I'll come back. Okay. Yeah. So in this 4 or 5 lines of code, what I have done, I have created an iterator. I have created an iterator using the collection class object. By using the collection class object, because I have to link this ITR with what collection class? That is linked by giving the object of the collection class. L1 is a linked list that I have created. So that linking is done using this kind of writing of the code. Then ITR gets associated itself with L1. Okay, what is L1? L1 containing the elements that I am inserting or deleting. Now, using itr dot has next, I'm trying to print all the elements in the order in which I have inserted. Now, I want to reverse the linked list. Can anybody comment what I can write for printing the iterator or for printing the linked list in the reverse order? Can anybody comment? I'm waiting for you.
Ma'am,
Yeah.
we
Yes,
use
Aditya.
itr dot last first, and then we use itr dot previous in a loop.
Correct. And when you are declaring ITR, ITR by default will be of ascending iterator. What is a normal data type of it? I cannot tell it as data type. Normal property of an iterator is it just thinks that I have to navigate from left to right. Whenever you declare an object of iterator, it just thinks that okay, I have to go from this position to the rightmost position. Okay. See, Java provides an extra feature for ITR. You can If you declare iterator as a normal iterator, it will be acting as ascending iterator. And when you want to call the reverse order iterator, last to first, right to left if you want to have, there is a special iterator called as descending iterator. So I'll be doing that in the next line of code. Just pay attention for this line of code. Now I have declared an iterator itr1 and called the descending iterator function using the same collection class object. Here I had written L1.iterator. Now what I have written? I have written L1.descending iterator. When I tell descending iterator, it means that I have reversed the order in which the iterator will navigate. Okay. See, the thing that I have written is first option. It is one of the options. The other option is already told by Anant. What he told Anant? Anant he has told me that declare an iterator and take has previous and use previous. So automatically it will be done. Automatically it will be done. Other than that, there is one more option called as descending iterator option. This talks about whenever you want to declare an iterator, that iterator can be initialized at the end. See, you have written both the for loops. For I equal to 0, I less than 5, I plus plus. Or you can also write I is equal to 5, I greater than equal to 0, I minus minus. I am doing the same thing in the descending iterator. I want to make sure that ITR1 is pointing to the last element and then I will move towards the 0th element. How? The iterator changes its direction automatically when I tell it as descending iterator. I minus minus will tell you that you have to navigate in the backward direction. So in the same manner, I minus minus is done by descending iterator. Okay. So there are two options available whenever you are declaring an iterator. You can make an iterator to work as a normal iterator operating as ascending iterator by calling the object of collection class with the function iterator directly. Or if you want to reverse the way in which the iterator is navigating in the collection class, then what you can do? You can make sure that while declaring the iterator itself, you just can make sure that you're calling the iterator as descending iterator. Then, even then, if you call has next, it will be moving in the backward direction. Don't think that it will be moving in the upward direction. It will be moving in the backward direction because you have declared the iterator as descending iterator. Though you are using has next, it is unlike the previous example. Has next does not move itself to the next. It in fact moves it to the previous. So this is first option. What may be the second option? I will just write the second option. So what has changed? What I have changed in these three lines? I have simply changed. I have kept the other two lines as it is. I have not changed anything in this. What I have changed? Instead of making simple iterator, I have made iterator as descending iterator. This is my first option. Second option is, as Anant rightly said, I can declare one more iterator. Say, let me name it as itr2 equal to L1 dot iterator. Okay, I have called an iterator by name itr2. Next, what I will do, I will write while itr2 dot has previous. What is the meaning of this? I have to start from the last element and I have to move towards the left hand side. Okay, not on the right hand side. So what is the next thing that I am doing? System dot out dot println of itr2 dot has previous. Please pay attention in the two categories that I have written. Both of them are doing the same thing. What is that? The first one that I have written, it is descending iterator. When I tell descending iterator, it makes sure that you are moving it in the descending order. The same thing can be, the same thing can be dealt using what is called as either has previous either by the combination of has previous and previous, or with a combination of has next and next. Okay, the same thing is being shown in the one more example that I have listed. Okay, let me go to the next example. So let me save this. I hope this discussion is okay with you. Okay, let me go to one more example where I talk about what is called as iterator example I have taken. So here explicitly I have taken an iterator, or let me go ahead from the initial part of this program. So what is that I have done? The first few lines are the repetition of the previous things. I have created an array list of type integer explicitly mentioned using the generics. Then I have added elements. Then I have created an iterator. I've created an iterator. Then I have made sure that I am moving in the forward direction. Then I am reversing it by calling the same iterator. I call it as iterator in the initial stage. Now I have called it as list iterator. See, in the previous class when I was discussing about, I have talked about two types of iterators. One is a simple iterator, second is called as list iterator. Okay, this list iterator is um, okay, let me go to the previous example. I think it is linked list, right? Okay. Um, okay. Yeah. Um, I had written this example previously, correct? Just pay attention, all of you guys. There is an error getting shown here. Okay, there is an error getting shown. Why this error is that? See, normally, if it is a normal data typed elements stored in any collection class, we assume that I have to have the accessibility of the elements in the increasing order only. Though these functions are available, but they are not part of normal iterator. They are not part of normal iterator. When I go to this example, over here, I have declared an iterator I of type list iterator. It is not the normal iterator. Either you can call it as a descending iterator or you can call it as list iterator. List iterator or the descending iterator both mean the same. Both mean the same. They can be used in the alternative option. When you call list iterator tells that you can iterate in any of the direction. In any of the direction. See, it can go from front to back or back to front. That is the use of list. Why this capability is available in linked list? Why it is not available in array list? Can anybody comment? Why it is not available in array list? Why it is available in linked list? Can anybody comment on this? What is the advantage of linked list over arrays?
Ma'am, first is it is not arranged in a like linear order
Correct?
in the linked list.
Correct? Wherever
Ma'am,
you want to
as you
store, you can
asked,
store. Yeah.
yes, ma'am.
Hmm.
Whenever we have created a linked list,
Hmm.
it is like internally it is not singly linked list. It is doubly linked list. That's why they have provided this method. I think so.
Okay. Okay. See, whenever you take a normal array list talks about only the next element. Okay. I here they always think that I'm moving in the ascending order only. From zeroth position, I will start and go up to the n minus one element. But when I speak about linked list, in linked list, I can insert or delete an element from anywhere. And it becomes so convenient for me to do all those operations without rearranging the elements. Of course, we are rearranging the elements. But as in case of arrays, we are moving every element bit by bit. Okay? See, that kind of freeness is available in linked list. That's why linked list is associated with both the things that are available. One is the normal iterator, and the second one that is called as reversed iterator. And that's why whenever you want to use has previous or has, whenever you want to use has previous and previous, you just have to have what is called as list iterator instead of normal iterator. I hope this is convincing for you. I hope that it is convincing for you. Please let me know. Unlike in the previous example, we have created two different iterators. First iterator to navigate from front to the last. Second iterator got created that is explicitly only for moving from last to the first. But here, when you see this example, I have created only one iterator. Just see this example. I have created only one iterator I by using what? List iterator. Using the same I have called has next and next, has previous and previous. Can you make out this difference between the previous example and the current example? This is how list iterator is much preferred or is much useful than the normal iterator, because you have that flexibility of moving either from the last to the first or first to the last. I hope this is clear for you. Please comment quickly so that I can move ahead faster. Is this clear for you?
Yes, ma'am.
Yeah. Can I move ahead to the next point? Whether this example I need to discuss again? The things are same, no change at all. Do I need to discuss it again? Let me know, please. You can even chat. I can see your chat. Yes, I can proceed ahead. Thank you. You want me to run this program? See, I'll be sharing all these programs to you, definitely. Okay, I think I have to remove this part. Fine, let me run this program. Yeah, you can just see. Using the list iterator, I can move in the both forward as well as backward direction. So next thing, let me take one more example where, see, in this linked list, I had created very simple linked list containing only simple elements, integer elements. Now what I want to store in one node more than one data typed information. Okay. Uh, See, when we used to do the linked list programs, then also we used to do either character insertion or integer insertion or floating point insertions. One data typed element we were talking about. Now, I just want to have an example which talks about more than one data typed elements are pushed at a time into the info part of single node. Okay, let us just go and check how I can do that. Now, I have created a class by name book. Guys, I will be going through this program line by line. Please pay attention. Uh, Let me just increase the size of this window. Okay. So I have a class by name book. In this, I have declared, similar to the structure that we used to create, similar to that, I have created various elements or various members of this class. Okay. So first is ID, then the name, author, publisher, and the quantity into which now how many number of books you want to order. Okay. Accordingly, I've created a constructor which does this kind of initialization. Okay. Using this, you are initializing the values that you are supplied. What for constructor is used? Constructor is useful for initialization only. Now, in the second class where the main function is there, in that I have created a linked list. Look at the generics usage, guys. Look at the generics usage. Generics can take any data type, even the user defined data type. Book is a user defined data type now, correct? Book is a user-defined data type now. Even that I have put in the pair of angular brackets. Okay with this? Can I proceed ahead? Okay with this or no? Please let me know. Okay with this much of explanation? Can I proceed ahead? Yeah, thank you. Now, what is that I have done? I have created one object of a new linked list that I am creating. And when I am creating the linked list, I am telling that linked list that you have to store the element information part in your each node which contain the data of the book data type, the data belonging to the book data type. Then using this book data type, now I will create three different objects and each of them I am adding using add function. Each of them I am adding using add function. So what I have done, I have simply created three objects of book class and assigned the values to them. Using the constructor of the class, the initialization gets done. Now B1 will have these set of values. When I call add on B1, all those values will go and sit in the info part of the node of the linked list. Similarly, I have B1, B2 and B3. This much part is okay for you. Any doubt in this? Any doubt in this? I have used the same functions that we have discussed previously. Any doubts in this?
Excuse me, ma'am.
Yeah.
Ma'am, can you please elaborate on how the class book becomes a data type?
Class book returns a data type. Okay. See, um, when I write Varshini, when I write integer here, what is its data type? Integer, what it is? When I write integer in angular brackets, what it is? Can you comment?
It's a it's a wrapper class, ma'am.
It's a wrapper class. So can you call it as a class? Integer is a class, correct? So instead of integer class, what I have done now? I have written book. What is book? Book is also a class. So the angular brackets prefers inputting of any of the class type, any of the class type. That class may contain its own definition and definition may contain its own set of members, data members, and those data members are all accessible through this book class. So generics allows you to have passing of a class which may contain more than one data member in it. If I pass integer, if I pass integer or if I pass string, what is the meaning of this string when I pass? It's a class. And string makes sure that you are storing more than one character, more than one character, but there is only one element available, there is only one data member available. What about book? When I pass, book is also a class, it's also a class, but it has more than one data member. This is how this book class is different from integer class. But whatever I'm passing in angular brackets, it's a class only, it's a class only.
Yes, ma'am. It's
I
clear.
hope,
Thank you.
yeah, I hope it is clear for you. Yeah. Now when I pass these things, when I pass these things to add of B1, you just have to map this to the thing that we used to do in data structures. Only then this will be clearer for you. When you call add function, it internally calls insert rare, because whenever linked list is there, by default insert rare will be taken care whenever you call add. But if you want to explicitly add the element at some other place, just like the example that we have discussed here. In this example, there is something called as in add first, add rare, okay, or add last. Explicitly, if you write add last or add first, only then the changes will be done. Otherwise, by default insert rare will be there. So any new element, if I write B2, B1, B3, then the first element inserted will be B2, second will be B1, and then will be the B3. The order in which you call the add function, in that order, at the rear end, the addition will be happening. Now, if you want to display each and every element, now I have to traverse through the list. Okay. See, the thing that I have discussed previously, I think probably in this example, no, collection example. Okay. In this example, I had discussed, sorry, array list example. Let me take array list example. Okay. In this example, where we had written that capital E, can anybody help me out? Where we had written that? I think in generics I had shown that example.
First class,
Okay.
you have shown that example.
Yeah.
Print array.
Generic print array. Okay. In this example, you have seen this kind of for loop writing. Okay. How we used to write? We used to write A is the A is the data type, space, element is the alias, colon, the source. In the same manner, I have written this for loop. So what is that? Book space B. What is this? This B is an object of class book. Unlike in this example, where generic print. Unlike in this example, we used to write type alias, correct? Type alias. When I write type and alias, let me just map that to here. Type, book is a type, alias. Every book has to be aliased as B. The meaning of this is the data type and this is the alias name, colon, the source. And this source contains 3 different nodes available now. In each of the 3 different nodes available, I have to extract each and every subpart of the node of the each and every subpart of the information. How many subparts are there? Let us go and check in the source class. There are 5 subparts in the info part of any node. So accordingly, if I call each subpart separately, only then I'll have the accessibility to each and every part of it. Okay, this is how I write for loop. For the traversing of the list. Now, whenever I have simple introduction of or simple information stored, single information per node if you have stored, single information can be extracted very conveniently. The single information can be extracted. But when you extract multiple data type elements available as part of single information, then you need to go for what is called as the for loop. I hope you are getting the difference between this and the previous linked list example that we have discussed. In the previous linked list example, uh, we never bothered about what is the data type of the element that I am taking out. It is just because there was only one information stored in the info part of the linked list. But now when I want to extract all the elements, then I need to talk about each part separately. Okay, let me just modify this like this: system dot out dot println of B. Okay, now let us check how this will work. Okay, let me just minimize this window a bit and let me run this code. What is happening? What is getting printed? Just have a look at the kind of the things that are getting printed. The B that we are talking about, B is only the address here. It doesn't talk about the content of the information of that node. I hope you are getting the difference between the previous example and the current example. Previous example was having only one information available, only one information available. but the current example contains more than one subparts in the information of each node. So in that case, I have to extract each subpart separately, and that's why I go for what is called as for loop. This is the generic for loop normally I use. I hope this is clear for you. I hope there is no doubt here. So you cannot write like this if you are using this kind of linked list where each node contains more than one information. You have to extract each information separately. I hope I'm clear with this. Okay. Okay. Now, let me take one more example. Okay. Let me close this. I don't require this. I'm done with this. I'm done with this. Yes, this is also done. This is also done. This is also done. Okay. Now, with this background, I just want to close this also. Okay. With this background, let me just go ahead in finding largest among the three elements. Okay. Largest among the three elements. Okay. There is something called as I hope the screen is visible to you. I hope so. There is something called as comparator in Java. Okay. Why this comparator is required? Normally, how the comparison of two objects is done? If you want to compare two numbers, what are the options that are available for the comparison? Can you comment? Options for the comparison of two numbers or two characters.
Mom, greater than, lesser
Greater
than, equal to.
than,
Correct.
less than.
Less than, I have greater than, I have less than equal to, I have greater than equal to, I have double equal to, and I have not equal
Not
to.
equal to.
Correct. These are the 6 options that are available when I want to compare any two numbers or any two characters. But can I use the same options for comparing two strings? Can I have the same options for comparing the contents of the node, two different nodes in a linked list? Can I have the same options for the comparison of a complex node than a complex node having more than one element available
Mom,
in the linked
technically a
list?
node is a ref. Sorry.
Correct. So you cannot use this kind of comparisons when you want to compare two objects. Okay, when I tell two objects in general, the objects may be of any data type. It can be of anything. It can be of an integer, it can be of a character, it can be two strings, it can be comparison of two files, it can be anything. Okay, any objects when you want to compare, because generics talks about the function has to work on any object that comes as an input. So can I have any such kind of option in Java which talks about comparison on any of the two objects that are given as input? Yes, that is available. And that is available as a class called comparator class, or I can, or comparator interface, which contains a class called comparable. There is a function, there is a class called comparable class, which gives me an option of comparing any two objects. Need not be only numbers. Any two objects can be compared and the result will be returned in the format in any of the three options. When it is lesser than, the meaning of that is the first object with which it is called, first object is lesser than the second object. It returns a greater than value. If it returns a greater than value, obviously the first object is greater than the second object. Otherwise, it returns a 0. Okay. Otherwise, it returns a 0. If it returns a 0, both are equal. Both are equal. So this is based
Um,
on this. Yeah.
Excuse me, ma'am.
Yeah.
Sorry for the interruption. Actually, I wanted to know, can't we just use method overloading for this? Oh, sorry, operator
Yes,
overloading for this?
yes, you can use. You can use overloading. Definitely, you can use. But uh, instead of doing all those steps, you if you call only compare to function available in comparable class, it does it.
So this is a little more developer friendly and it
Yes,
speeds
yes,
up the
yes. Yeah,
development
yeah, yeah.
process.
That's all. That's all. Okay. So now this comparable class has a function called. It has a function called compare. So what this does is it compares any two objects that are given as input. So it has to be called in this manner. Object 1 dot compare to of object 2. So it compares object 1 and object 2 of any data type, but provided object 1 and object 2 have to be of same data type or same, they must belong to same class. Only then this comparator will provide you the proper answer. Okay. So with this basic knowledge, we'll just go back to one such example which uses the comparator. Very simple example I will take. Okay. I think I'm left out with only 2 minutes of time. Um, so can you just join back so that we can complete this example and then you can join for the MEPIP class. Can you join back for 15 minutes?
Yes, ma'am.
Yeah, join back after 2 minutes. I'll be stopping now.